Happy St. Patrick's Day to all those of you who are in the U.S. or at least elsewhere. And I shouldn't say U.S. only, it's not a U.S. holiday. Anyway, drink responsibly, as they say. Have fun. In time, it looks like we're just about ready to start. So I would like to introduce myself, Paul Siegel from Starweaver. This is the second of a 7-part series on cybersecurity warrior certification. This is leveraging Wireshark for security, and this is going to be Kevin Cardwell doing the presentation. Again, I'll take about a minute to do an introduction. Who are we? We're Starweaver. We are a company that does live and online education for large institutions around the world. I think you've seen many of these names before. There are many others. We've pretty much worked on every continent and in many different languages, ideally providing customized solutions, so-called solutions, training programs for organizations. We have hundreds of online courses, but we also do this in live and online format. So whatever works for us, you, the client, to make sure that you're getting what you need. Cutting edge technologies, traditional enterprise IT, Scrum, Agile, Lean, Kanban, and et cetera. Finance programs that are sort of, I'd say, more esoteric finance, capital structure, corporate finance, valuation, derivatives, that kind of stuff. And all sorts of business programs, business skills. Live and online, as I said, so you can see this stuff streaming online. You can actually go into a library. This is part of our Starweaver Institute certification program. There are several that we've already launched. We've done this for many tens of thousands of people in the past, so you're in good company. Again, this program is a 7-part series. It's focused on current issues in cybersecurity. Each one is 45 to 60 minutes long. We try to keep it precise. Kevin's got a lot of material to cover. There is a short question, a test at the end. Take notes. Come back to the videos. These are all available to you. Rand has been diligently Rand has been, actually I should say Rand, you should record this session, but Rand has been diligently recording these sessions, and at the time of the get-go, you'll see it be recorded. It'll be available to you, and you can see them afterwards and to review the content. Again, what's the purpose of this? I said this before, so you can understand the fundamental issues of cybersecurity today. This learning outcome is the second one, understand the key tools available in Wireshark. The next one's about explaining the essential cybersecurity defense strategies, and what is a cyber range, and how to build one, how to do penetration testing and intrusion analysis and intrusion handling. Again, this is the program today. It's the second part. There are the other ones. They're a little spread out, but this is based on Kevin's schedule, and hopefully you'll still stay with us. We'll send you plenty of reminders. Kevin has introduced himself before, but he's an expert in this field without any question. If you have any questions, certainly he'll be able to address them. Again, I've mentioned that you get a free course. Again, just click on the link on the right in the chat box. This is the link for those of you who did not take it down. Sorry I'm going so fast, but I really wanted to get to the material. There's some contact information. Please feel free to reach out to us. Also send an email to helpdesk@starweaver.com. Go on our website. And I'm going to now, you can go on our website to get a chat with our chat people, and they'll hopefully be able to give you what you need. Again, passing this off to Kevin. We'll take a second to set himself up, and take it away, Kevin. Thank you so much.
Okay, thanks a lot, Paul. Hopefully everybody can see my screen.
We can.
And welcome to Leveraging Wireshark, Protocol Analysis for Security. What I want to talk about here is things you can do with Wireshark to check your security. One of the things is, we know we all wanted big data. Well, we have big data, and unfortunately it's too much data really to monitor with what we have today. So what we want to do is, we want to actually, and we'll do this when we get into the next webinar especially, we'll talk about how to do segmentation for your defense, and then in each segment you can look for things that shouldn't be there. And that's kind of where I set this up. So what we're going to do is, we're going to review the network protocols again. For those of you who might have missed the first one, just go a quick review of that. We're going to examine IP protocols, and we're going to identify components of your transport protocols. That is mainly UDP and TCP. And then we're going to look at some characteristics of network connections. And then I'll get into Wireshark and show you some of this actually in the Wireshark tool itself. let's get started. Of course, IP is the main internet protocol. And what happens is, as I said in the first actual webinar, everything's encapsulated inside IP. ICMP, UDP, TCP are all contained within that IP protocol packet. So when you're on your networks, you want to look at the traffic that's each segment of your network. You've probably already got monitoring tools, I mean, their net flow with your Cisco devices, those types of things. You probably have a lot of these things already set up. So what we want to do is we want to start leveraging that and looking at the network packets. One of the worst things is when you get a tool that does not give you the actual packet. So the first thing I do when I set up a SIM for a SOC or anybody else is make sure they can pull up the actual network packet, because when you have the packet you can identify and see what's really taking place on the network. So IP, of course, is the actual workhorse of the network. The thing is, IP is the upper level protocol. The reliability is contained within the actual encapsulated protocol, and that's provided with TCP, Transmission Control Protocol, which we talked a little bit about in the first webinar, and we'll talk a little bit more about it now. The main thing to remember is this is what the IP header looks like in Wireshark. Remember, machines don't care. It's binary to machines. So since it's binary to machines, they can read it in any binary format. This is where the hackers are winning the game. The hackers always look at hexadecimal or the binary format, and they modify, or what we call obfuscation. And when they obfuscate it, they make it harder for the actual monitors we have in place or the devices we have in place to determine what's really there. Because remember, the machine's going to interpret the binary. It doesn't care about anything else. So the hackers have learned many years ago that if they obfuscate things, or what we call craft packets, and do something different than the norm, actually a lot of our tools, the reaction is to pass the traffic and not actually reduce it to its lowest form. It's kind of like fractions. If you remember in mathematics and doing your fractions how you had to reduce them to the lowest form, it's the same type of concept. Our application developers, they have to reduce everything to binary to be able to monitor it properly, but they don't always do that. This slide here, the area in blue, is actually the entire IP header. So the Internet Protocol header is represented there in that area of blue. And what it is that 4 represents IP version 4, and that's where the start of the IP header is. So where this is important for our security is the encapsulated protocol. So when we look at this, we see that the IP protocol type, the encapsulated protocol, is located at the 9th byte of the actual IP header. So if you start where the 4 or 5 is, start with your count of 0 and go up 0, 1 through 9, on the 9th location you'll identify the encapsulated protocol. In this case, a 6. A 1 is ICMP, a 6 is TCP, and a decimal 17 or an 11 hexadecimal is UDP. So this is how you analyze the different traffic, and you want to make sure that what's your monitoring devices are telling you is actually what you're seeing. Because as an attacker, I can encapsulate ICMP but tell you it's really TCP. Right? There's things I can do to modify using a lot of tools that are out there, and we'll see some of those as the webinars progress, but you want to make sure your devices don't fall for these simple obfuscation techniques. And that's, again, the identified encapsulated protocol, what's contained within that packet. And that's the key for analyzing what's taking place in your segment. Okay, so here's the actual example. Won't spend too long here, but there's the 1 for ICMP, the 6 on TCP, and the 17 or 11 hexadecimal on UDP. That's exactly how it looks like on the wire, but rather than read binary bits, because as you can imagine, looking at a bunch of 8 bits of binary instead of these 2 hex digits, that could become very cumbersome. So rather than do that, what we do is we actually use hexadecimal. And 2 hexadecimal digits represent 8 bits of binary. Just makes it easier to read for most people. Most people don't want to read binary. Some do, but most don't. Okay, so what happens in your network is you have this local area protocol that maps the IP address to the physical MAC address. It's called ARP. Address Resolution Protocol. So every time an actual information goes out on your network, the IP address, this is important, only gets you to the network segment of the device that controls that IP segment. So the router in most cases. Router for those of you who are in a country that call it router. So again, when you get there, the data is delivered to the MAC address. So this ARP protocol, this Address Resolution Protocol, that's a layer 2 protocol, it provides us the physical or the MAC address for the destination we're trying to reach. And now as you can start thinking like the attacker, as we want you to do as time goes by, that can be spoofed or masquerade. Remember, our attack against authentication was masquerade. So we could spoof or masquerade as somebody else by spoofing a MAC address, which is a very popular layer 2 attack. All right, so this is actually what it would look like in Wireshark. So the middle window is represented there at the top, and then the bottom is actually the breakdown of the actual information that's in the header. So in Wireshark, we can customize it, because if you look at the top image, you see we're seeing this Thompson, we're seeing this Honair, all these other Intel, that type of stuff. We're seeing the name. The name is probably not what you're going to want. You're going to want the actual MAC address itself. So as you look at the bottom image, you see the MAC addresses. And that's what you want, because a lot of times what we do in organizations is we set up a MAC address structure. So we assign our MAC addresses. So it's real quick to go into a segment if you suspect somebody's clicked on an attachment, maybe you got some ransomware, all that type of stuff. You can real quick go in there and see if there's any MAC addresses on the network that shouldn't be there. Or even Wireshark will tell you if there's a duplicate MAC address, which is a common attack. We like to attack by using duplicate addressing. That's an old attack from many years ago, right? Those types of things. And what you see there in black, if you notice that highlighted in black, that's an ICMP type 3 code 3, destination unreachable, port unreachable. That's because the request before that was a UDP protocol going to SNMP, Simple Network Management Protocol. That means it went to port 161 and the response was ICMP back. Well, why is that? Because in UDP there's no connection. So since there's no connection, we have to use ICMP to tell you the port's closed. In this case, that port is closed. All right. So as you get through and you start practicing and analyzing, this is what you want to focus on. Now again, I said earlier, there's too much data on our networks today. That's a given. That's what we're dealt with. We're dealt with way too much data. If you think you're going to monitor all your data and figure out what's going on, very difficult to do. Yes, we have lots of tools that help us, those types of things. But what I start teaching people in defense is start looking for things that shouldn't be there. And then when things that shouldn't be there, go there from there. All right? So as I said, UDP is connectionless. So you look at the example of the UDP header here, you see it's quite simple. The UDP header is not a whole lot of information. And if you remember from before, that's because UDP is connectionless and it's used for speed. It's mainly our protocol for streaming video and all that type of stuff, because UDP doesn't have to set up a connection, as you'll see TCP does when we get to that. So this is a simple example of another powerful thing of Wireshark. In DNS, the domain name system, distributed database, maps names to IP addresses. Most of you are probably familiar with it, and you've seen it before. DNS happens on our network constantly. So that's what I've done here. I've used a powerful technique here in Wireshark called filters, and all I've done is filtered on port UDP 53. And you start looking here, you see queries and you see responses. So just by looking at this, you can start seeing where your network is looking at. So to give you a preview of what you want to start looking at in your organization, you should never see in an enterprise organization especially a DNS query coming from a client going to the Google DNS, which is located at IP address 8.8.8.8. That's not supposed to happen in modern day networks. Yeah, a lot of people like to use the Google DNS, that's true. But in your organization, if you're allowing your client machines to direct query the DNS, you're making a huge mistake when it comes to security, because 90% of all the malware will do a direct DNS query from the infected machine out to the Google DNS. Or these older ones, which are represented here in this Wireshark trace, because I'm old school, I remember the UUNet and the level 3 and that type of stuff, their IP addresses are 4.2.2.1 and 4.2.2.2. So as you see, that's the communication here taking place. This should never happen in your organization. If any DNS traffic's going out, the source of that query needs to be your internal DNS server. If it's not, you probably don't have your DNS configured properly, or more importantly, you don't have any ingress or what we call egress rules going out. So again, when we start talking about defense, by doing this, setting up these simple things where you don't allow a direct DNS query, we call this a black hole route. If you don't allow that direct DNS query, guess what? You block 90% of the malware out there. Then there's another technique where the ingress filtering, by using that we block 65% of the malware and the ransomware infections. So this is the power you have control of. This is what you have to start doing in your organizations. And here's what a query message looks like. So remember, the DNS is just a query out to a DNS server that says, hey, do you have this address? So Yahoo, for instance. I go www.yahoo.com. Do you have the IP address of www.yahoo.com? If the answer is yes, they come back with what's called a DNS response. And that DNS response is what you're going to take and use to go to the IP address of that machine, and then of course it has to get the MAC address to get the physical address, and then you finally will actually be on your website. Now the key here is DNS was created many years ago, just like TCP, when the internet was very small. So it's based on that principle of trust. So everything we've looked at here can all be poisoned or masqueraded by attackers. And that's a lot of the attacks still today, even though they're old and they've been there for a long time. There's no layer 2 protection, layer 3 protection in most of your networks. Most people don't bother with it. They're all up there playing at the application layer, like I taught you before. And they're thinking the firewall is going to protect them. Well, the firewall only is a gate. So we have things that has to get through the gate. We have to do monitoring once it gets through the gate. So that's your intrusion detection, intrusion prevention, and those types of things. But again, they have to recognize these techniques and tactics of an attacker of obfuscation. Right? Now the one thing you want to look at here as we look at this DNS response is that one I just highlighted there, the additional records. This is where you get into trouble, because DNS servers sometimes will cache the entries in that additional records. And if it's an additional record, it should be related to the query. But what we found is, and this is some famous cache poisoning DNS attacks, if you go look up the DNS out of bailiwick attack, or the name for the person who actually produced it and showed it at a conference, Dan Kaminsky. If you go look up the Kaminsky attack, you'll see how we use these additional records to do cache poisoning and DNS poisoning attacks, right? So again, for security, you want to make sure none of these additional records are showing the banks pointing to some address that's not really your bank, right? Those types of things. That's important. Then the one right above it, the authoritative name servers, that means these hold the start of authority, or what we call the SOA record for the DNS for these sites. So these are the types of things you can look at when you analyze your traffic. Now remember, the data is huge, so we want to start looking for things as an anomaly. So usually if you get some form of an indication that maybe something's happened on one of your segments of your network, that's how you would use and do this type of analysis. And we'll cover that as we continue through. Okay. TFTP is UDP. It's originally created for diskless systems. It's lightweight and it uses port 69. So this is what it looks like if you look at it in Wireshark. Now since it's UDP, guess what? There's no way to determine if the connection is going or coming, right, to or from. So what we do is we have to send back an acknowledgement packet. But when you look at this, look at the first top line. Packet number 148. It's a read request for this file, ctimer.exe. And if you go, what's the first thing that takes place? Address resolution protocol. That's because I need to know the MAC address of this 192.168.2.147 who's trying to communicate to my TFTP server. So once I get that MAC address, so you see there in the packet 149, the first one in gray, who has 192.168.2.147? Tell me. That's exactly how it takes place on the wire. That's what it looks like in binary, but here we put it into words so it's easier to read. Once the MAC address is returned, the data flows. This is how every connection takes place, be it UDP, TCP, ICMP, whatever it is. We've got to get to the location of the segment, which is identified by the IP address, and then from there we do the MAC address, and the physical address gives us the location to send the data. So look at the data. As soon as the data flies, it goes in 512 byte packets in block 1. As soon as block 1 is received by the receiving machine that requested it, you get an acknowledgement for block 1, then block 2, block 3, and so on, until the last block is sent. So when you look at this, this is UDP. but there's no connection set up. So we have to send back an acknowledgement packet. That's the downside of UDP. Here's what it looks like if you look at it in the header. So you see the read request here. This is the read request for the source file, ctimer.exe. So that's that first packet at the top of that image we just looked at. This is just looking at it in another way. And there's the actual source file. So where's this come into importance? This comes into importance because if you go to a segment and you're trying to figure out from your network traffic what's taking place, you can identify all the source files that is in that network trace using some techniques of filters, those types of things. And you can determine what files were transferred to and from that segment. And maybe who transferred the files to and from that segment, so you can identify either the source of the attack or maybe the insider who's transferring information back and forth. Again, this is all powerful with Wireshark. All right? Okay, so this is what the data packet looks like. So now we've got block 1, the opcode down here in the bottom says Trivial File Transfer Protocol, 512 bytes, and the opcode data packet 3. Okay? So what you see here is block 1 has actually the data been sent, and the data is 512 bytes. Well, how do we know the data is received? And there's our UDP protocol type at, remember, the 9th byte offset starting from 0 at the 4.5 of the IP header identifies the encapsulated protocol type. So in this case, it's UDP. Okay. Now, here's the acknowledgement, because remember, block 1 was sent, but there's no connection. So we have to have a mechanism to tell us block 1 was sent, and that's an acknowledgement coming back. So this is the process of how UDP or TFTP would look like on your network if you have TFTP. A lot of you out there might be saying, wow, TFTP is bad. It's true, it is bad, but it's still used by a lot of organizations to do their uploads to their routers and their devices, because that's what it was created for. And we'll talk in defense about how you can do some things to make it even less of a risk. Okay, so now TCP. Remember, UDP required an acknowledgement. TCP does not. Why? It's connection oriented, right? It's reliable. It gives you that guarantee of delivery, and it's a byte stream. That means it's interpreted by the application and not TCP. So you look at this now, the TCP section here, you see our flags. And we did this in the first webinar. The flags, the 6 main ones, start there at the 3rd one, urgent. Urgent means there's no buffer, do not buffer my data, send it directly into the stack. It's a request. Of course, the receiving station always makes the decision. Acknowledgement, which is the 1 here, which means the acknowledgement flag is set, means I'm acknowledging something you sent. The push means there's data in the packet, which is very important for us. The reset is an abnormal close. So if you go down to your segments and you see lots of resets, there's something wrong. You shouldn't see lots of resets. If you see lots of resets, that's usually an indication of a port scan or something that an attacker and an adversary is querying or scanning or doing something, they're not finding it. So the port scan resets are definitely a concern. And then you've got the SYN or the synchronize, which is the open the connection with me. And you got the fin or the finish, which is the normal close. Okay? And then you got the data. So if you look down there, we've got a 1460 byte data, and that's because of the MTU, maximum transmittable unit, right? And it's 1500 bytes minus the 2 headers. That's why it's 1460. And you see that's the data in hexadecimal. Of course, the data is in binary, but we're representing the hexadecimal because if that was 8 bits of binary per every 2 bit or 2 numbers in hexadecimal, that would be kind of difficult, right? So this is what it looks like. This is what we call the 3-way handshake. The SYN, the synchronize, says open a connection with me. The acknowledgement says I acknowledge your synchronize, and we also do a synchronize and say open a connection with me. And the 3rd step, the acknowledgement, says I acknowledge your synchronize. Why do we have the 2 synchronizes? Because TCP is full duplex. You can send or receive either side at any time. So if you've got a megabyte of data, they got a byte of data, they don't have to sit there and leave their side of the connection open for 999,000 more bytes once they've sent their 1 byte. They can do their business and move on and leave your connection open so you can send your data. And this is what it looks like in Wireshark. In this case, we see a SYN or a synchronize going to the HTTP or port 80. Port 80, of course, is HTTP. And then we got the SYN ACK, the ACK. The important thing, remember in UDP, we did not have a connection. That's why it's so fast, and UDP is connectionless. There's no guarantee of a connection. But here, as you see, there is a connection, and that's why we have guaranteed reliability because of the connection. This takes place every time a packet flows. If it's TCP, the connection is established and set up. If it's UDP, the connection is not established. It's just the data sent. Okay? Remember the analogy. The best analogy of that is going to take your letter to the post office and mailing it. Okay. Now, this is what happens. This is looking at the network connections on a machine. So if you use the netstat command, which I'm doing here with the -A, it says give me all netstat by numbers. So don't give me any DNS resolution, just give me the numbers. Okay. And then I pipe it to a string called find str for find string and say give me established. Because what happens when you have that SYN ACK, and that ACK, that connection's established. So now you have an established connection. From a security standpoint, you want to do this on machines if they're acting funny. Those types of things. Why? Because when you look at this actual middle address, that's who the connection is to. So if that connection is to some IP address out there in a country you don't want to be connected to, you've just identified potential signs of compromise, right? Those types of things. And the last thing I want to talk about on this slide is when you take that IP address and the colon in that number, that IP address bound to that what we call port, that is a socket. Every one of your attacks, anything that takes place has a socket that the data gets to the machine or the victim from. Remember that. Unless I physically sit on the machine, I had to do it over a network. So if it's TCP, it has to have a socket. Right? That's the socket right there where you have that connection. Now if it was UDP, we wouldn't have any address in the middle there because UDP is connectionless, right? But in this case, being TCP, we have an established connection. An established connection means that three-way handshake has been completed. And again, it's good for looking for signs of compromise in case somebody is in this IP address block that shouldn't be there. And we do this because there's a lot of known malware nets, the ransomware, the botnets, those types of things. You can go into this and just start looking for the ones that are there, and there's tools that will do it as well, and you can do it through Wireshark as well with their filtering. Right? So again, we're just showing you ways to use Wireshark to look at your network traffic, and then you go back to a potential compromised machine, as this shows here, and look if that machine has something on it that identifies the compromise. And we'll continue to build our skill set as we go. I mainly wanted to show you that this socket, and the best analogy of a socket, think about power. Most of us out here, we have our devices, we have to have power. Well, you take that device and you plug in its charger into a receptacle or whatever you want to call the type of thing, and once you plug it into a mains, as they say in the UK, once you plug it into that receptacle, you get power to your device. Sockets are the same way here. Once you create the socket, you plug the data into it, you get the data to the device, right? All the data in TCP has a socket, and that socket is how it gets to the actual connection. Now, there's UDP sockets too, but it's a little bit different. Okay. Now, when I opened the connection, I had 3 steps. When I close the connection, I have 4 steps. Why the extra step? Because I've got to close both sides. Remember, I told you there is 2 sides of the connection, and that's because TCP is full duplex. You can send and receive on either side. So in the close, 4 steps because I got to close each side. And as you see here, these are the 4 steps of the connection. If you look at the image, it was actually a really good image because I actually opened the connection and closed it and didn't get any other noise in between it, which is hard to do on a modern day network, especially a Windows network. But you see the first 3 packets are SYN, ACK, ACK. And then immediately I closed it, FIN-ACK, ACK, FIN-ACK, ACK. And you see how the process works. And you see the second and third are actually coming from the receiving station. So again, it's just showing you how the process works. This is the abnormal close or the reset. As I said, if you see lots of resets in your organization, you might want to try and investigate and see, why am I seeing all these resets? Lots and lots of resets, usually their indication, well, it could be a malfunction, could be software running amok or something like that, but in most cases, a reset identifies an abnormal close, and that's normally because somebody is probing you or looking for information that's not there, and a reset can give that away. So data flow, if you remember, TFTP required an acknowledgement. TCP, no acknowledgements required. It uses a sliding window. This allows the sender to send multiple packets. They don't wait for acknowledgement. It gives you fast speed, and that's what TCP gives you, fast data flow. Okay? Okay, so here's TCP. So when you look at this first packet, packet number 419, and we're going to look at this live on Wireshark with the actual packet trace I've created here shortly. You see the SYN, the SYNACK, and the ACK. You see in packet 424, the response is ZFTP server version 3.0, build 2008, da 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 da. That's leaking too much information. So from a security standpoint, if you go into your network traffic and you start seeing these banners, that's what we call this at packet 424, is a banner. You start seeing these banners like this is a problem. Because by seeing these banners, this is telling you that you're leaking information. Because as an attacker, what I'm going to do is I'm going to take that banner, ZFTP server version 3.0, and I'm going to get on the internet. We love the internet today. I search all around the internet and look for vulnerabilities in that ZFTP server version 3.0. Next, I look for exploits. If I find an exploit, now I'm going to exploit and own your machine. Right? And remember, this is huge today because we have all these cloud-based scanners, a lot of different things out there that you can do this. So that's a concern. So this organization needs to do a better job of doing that or camouflage it and see what they can restrict. Because any service that has a banner, try to restrict the banner to the least amount of information as possible or obfuscate it and pretend to be something else. So here's your data flow and what I'm showing. So when you look at your FTP, you got your script.txt, which was the wrong file. It was a script with a T. So as you look here, but look at packet number 1024, right? So you look at packet 1024 right here, where I'm moving the arrow to right now. So it says 3COM, 3C daemon, FTP server version 2.0. That's a banner that's telling me this FTP server is running this version of 3COM. And yes, that is a vulnerable version of 3COM. And because of that, now I've got information that I can use. And remember I told you in flags, we use the push flag to identify data? This allows us right here. When you look at the push flag set, that one means you've got data in the packet. Well, what's the data in the packet? The password. Right? So again, those are the types of things we want you to understand. Once you start looking at these types of things, immediately you can find out if anything's being passed in clear text. In this case, the password is password, of course, which is good, but we're doing it for an example. The other thing I want you to look at is the bottom last actual packet, 3739. See how it says closing data connection, file transfer successful? And then 1041 file status OK, opening data connection. That's because the files transferred all within and interpreted by the byte stream, right? Remember in UDP we have to have the acknowledgement. We don't need the acknowledgement here because the connection's established when we set our initial connection up with the three-way handshake, the SYN, the SYNACK, and the ACK. Okay. So here we go, we look again. This one's a little bit different because now what I'm doing is, look at my packet number 118 at the top. I'm doing a DNS query for Ford.com, www.ford.com, and I get a response back where Ford.com is located. And as you see, they're being edgesuite.net, which means, of course, they're outsourcing their DNS. And then now packet where the green starts, where I got number 120 is my SYN packet, and then I get an ARP in between there. But then I've got my SYNACK at packet 122, right here. So that SYNACK right there identifies, and then the ACK. What did I tell you after the three-way handshake? Immediately after the three-way handshake, data flies. The next thing is the GET request. So if you look here at packet 124, the GET request, get/HTTP 1.1, that is actually the connection to the server that says give me the page located at document.root, right? And I'm saying using the HTTP/1.1 specification. And as soon as I do that, the page comes back. This is the process of how we would look at traffic. Because in your organization, you should never allow a head. If you allow the head command here and you get a 200 OK back, that's a problem. You should only allow gets and those types of things. So there's all these things you can do from a security standpoint just by going to look at the network traffic on your network. All right, so I like to tell everybody, yeah, there's tons and tons of data, but just following some of these simple techniques, immediately you can follow and tell your organization or your clients, if you've got a contract, say, you know, you're not following best practices of security because I found this, XYZ. Okay. And this is what it looks like if I do what's called follow the stream. So what I've done here is I've taken that same exact trace using the power of Wireshark, and I've used follow TCP stream. So when you look here, the response by the server is this 200 OK. But more importantly, from the standpoint of your security and leveraging Wireshark for it, look at right below the 200 OK, the server line. See how it says IBM HTTP server 6.1.0.21 Apache /2.0.47? Too much information. Now that leaked information can be used to identify the server is 2.0.47 running on an HTTP server that's produced by IBM. More importantly, the Apache 2.0.47 has vulnerabilities that are exploitable. So now I can go in and I can literally exploit this target and compromise the machine. So that's a concern for this organization. And that's kind of what we wanted to focus on here so you get an idea of doing it. Now again, like I said before, we give you a little bit of information each of these webinars, and then you have to go do some research. But that's why if you get stuck, reach out. You know, reach out to me on LinkedIn or whatever, and I can help get you unstuck. Again, I got a motto. If you're reading in my books, my motto is, frustration's good. It's when we learn. But don't get more than 90% frustrated, because then that's counteractive. So if you get that frustrated, take a break, walk around, or contact me to bring you back down to below 90 to about 85. Okay? All right, let's look at Wireshark now. We're ready for a demo. So I've got a Wireshark trace here that's just like we were doing there, and you start looking through, it's got different types of things. And this is this Vulcan 4, that's the name of the machine, and that's just Windows. That's Windows being Windows. Windows makes lots of noise, talks all the time, and you see I had Dropbox connected as well. Okay, so when I go down here and I start looking at, everybody see this? There's my ARP, Address Resolution Protocol. Who has 192.168.20.1? Tell me. And again, once again, we're seeing that as soon as the IP address is connected to, the first thing you do is you do an ARP request. And that ARP request gives you the MAC address. Okay. So now when we look at this, we see there's the MAC address, 005.056C00002. If any of you don't know, that's VMware. See that? I'm talking to virtual machines. You can see that now with the VMware being identified by Wireshark. So again, if you know in your organization on a segment, you have all Intel cards, and you pull up Wireshark and you see a foreign card or one you don't know, Huawei or some other type of thing, guess what? You've got an intruder on that segment, right? Somebody's plugged into that segment, a laptop, or done something they're not supposed to do. Again, or poisoned in the MAC address, those types of things. These are the types of things you want to start practicing at. So then I got this write file right there, write request file trophy.txt, okay? So now what that's telling me is I'm asking for trophy.txt from the server. The acknowledgement block says, okay, trophy.txt, so if I go use this capable follow UDP stream, a great capability of Wireshark, that shows me the actual contents of the file. And this is a little trophy file I created. This is an attack you are owned. So just by using Wireshark, a text-based file I've identified was transferred to and from this segment, and I've got all the details of who transferred the file to and from this segment. I've got enough to start doing my intrusion analysis and my incident response, which as we continue to build your skill set, we'll go through this more and more. Okay. So this is the entire session. So it was block 0, remember 512 bytes, it was a small file. Block 1, which even tells you it's the last block, and then the acknowledgement of block 1. And what was that? That was the entire contents of that trophy.txt file. That's a text file. But what about if I do TFTP and it's not a text file? Now we got a little bit of a challenge, because this file here, msizap.bk, is actually not a text file. So now when I right-click follow UDP stream, now it's a little bit harder, because now it's what? It's binary, it's executable, it's in binary image, executable. But look what else. we can read a lot of the information even though it's a binary file. We see this, see that MZ right there? MZ identifies it as a binary type of file, and there's a few file types. You can go read them if you want, or shoot me a message. I can always explain them to you. But if it starts with an MZ, that's telling us this is a binary file. So I can identify the name of the file. I can identify some strings in the types of the file. In this case, it's usually shell 32.dll, other types of Microsoft things, but I can't read the file because the binary data in the file I'm not going to be able to read. I'd have to get it in a debugger and all that type of stuff. So I can't read it in here. I can pull it and do it other ways, but in this case right now I can't read it. And it says this program cannot be run in DOS mode. Dead giveaway that you do have a Windows executable. And then when you start going down here, there's more and more stuff. It's telling me the info using the package, the products. So even though it's a binary file, there's a lot of things I can get and get information from the file, which is good. That's the power of what we want to be able to do when we're doing our protocol analysis. Okay, let's look at FTP, because that was TFTP. Now let's look at FTP. So if I come down here to where my FTP packets are, and I've got right here, let's see, file transfer, let's get up to the, there we go. So here's FTP. So we got quite a bit of FTP up here. Remember what we said? User logged in, all that type of stuff. So you can manually go through this, right? Find the three, there it is again. Remember, it starts with ARP. There's our address resolution protocol. There's the three-way handshake, SYN, SYN-ACK, and ACK. And as soon as I get the three-way handshake, the banner is returned. In this case, it's that 3COM-daemon FTP server version 2.0, like in the slide, and it's a vulnerable version of 3COM-daemon. Now when I right-click it, now when I go to follow, it gives me follow TCP stream. So now the TCP stream is going to be from the connection opening to the connection close. Look at the data I have. I have that it's a 3COM-daemon FTP server. The username's Kevin. The password's Kevin C. And they're logged in. There's the information for the login. And they do a listing. And LST means they listed files that was there. And look what they do. They request trophy.txt. About to open. File transfer successful. Remember, this is all taking place in this segment. And then they do the MIZAP exe and identify. So just by looking in Wireshark and using security, I know immediately what's been transferred on that segment. These are the types of things you have to do when we start getting into segmentation isolation. You'll be able to look for things that shouldn't be there. Because when we teach you the proper way of doing segmentation isolation, you should know exactly what's supposed to be on that segment. So you look for anything outside of that on that segment, you've identified a potential intrusion, which today pretty much leads to ransomware and all that type of stuff. Okay, so you saw how that was done. So that's the main thing with FTP. A couple more and then we'll open up for questions. The other one I want to look at is HTTP, right? The HTTP is good and that type of stuff. And I showed you the GET request and those types of things, right? So that, we'll just see if we got any HTTP in here. Lovely thing here, powerful thing in Wireshark called filters. And you see we do have some TCP, right? We've got some HTTP. So what you're looking for in HTTP, again, you've got your three-way handshake, but these GET requests. Remember I told you about the GET requests, those types of things? That's identifying that there was a GET request to the actual server, and you're looking for a 200 OK. If you get a 200 OK, that means the server accepted the request. So now we just right-click it, follow TCP string. And now, once again, here we go. Anybody see this? Look at that. Now I've identified this segment has a very old Microsoft IIS server. And some of you are saying, oh yeah, you staged that. Well, I did stage it as a demonstration because I didn't want you to see the actual site I found it on. Most of you know Microsoft IIS 6.0 had lots of vulnerabilities, lots of bugs, and has been gone for a long time. But guess what? I just found it 6 months ago with a client, and they didn't even know it was there. Why was it there? They put in a new web server, but somebody left the one plugged in. So it was plugged in, we found it. Remember, our job as professional security testers, penetration testers, whatever you want to call it, our job is to find the risk to an organization. This was actually reachable from the internet, a Microsoft IIS 6.0 web server from the internet that should have never been there, but they forgot to unplug it. That's our job as testers, to find that, all right, those types of things. And that's the process of how you do this, right? So if I continue down here, and I look, now my favorite way to do it, I just like looking down here in the bottom window, but for simplicity for you guys, and there's another 200 OK. So now I right-click that 200 OK, and now I got more data, and I start coming down here and I start recognizing some things. Some of you out there might recognize it, some of you might not. Number one, there's a session ID, which I could use to attack and all that type of stuff. But number two, anybody recognize that? Records are below. Yeah. That is structured query language. So when I start looking in here, anybody reckon, I mean, I've modified them, obfuscated them. That kind of looks like credit card numbers, yeah? That's exactly what that is. That's credit card numbers. Then I start coming down here and I look, well, what the heck was taking place? Well, the table is called dbo.table1. I've got that now from the trace. But right here's the concern. That's the query that was credit card name, CC name, credit card name, not very intuitive here. The query is a single quote or 1 = 1 --. For those out there listening, maybe you've heard this, maybe you haven't, but you can hear it now. That's the classic test of an SQL injection. By doing that, it does a query and says, give me the names of the database. And the -- in SQL means treat the rest of the field as a comment. So if you see this CC password, so in this login, there's normally a username and a password. In this case, CC password, credit card password. As I said, not really intuitive naming here. A lot of people do that. So when I see that CC password, guess what I just found? SQL injection. And it was successful. Why do I know it was successful? Because of right here. All there's the data. That's the data, the SQL injection. So most of our tools out there, Web Inspect, most of your web scanners, all that type of stuff, they will find these types of things, and you can find them manually as well. But again, when we're using Wireshark to leverage security, we want to look for things that are like this. This is actually me carrying out an SQL injection attack against a database that I created, of course, because I got all the numbers here obfuscated, but again, it's emulating what we do in the real world and do it all the time, and I'm carrying it out with the classic single quote or 1 = 1 --. Now, there's a lot of different ways to do it as well, but I wanted to show you what it would look like in the actual Wireshark trace. So when you go and you look at this, all this was done by, in this case, me, but it's a perpetrator, right? So you start looking, you start saying, file not found, JavaScript, all this type of stuff. But as long as I keep seeing these 200 OKs, those 200 OKs are indicating that the web server accepted the query. If the web server accepts the query, then that gives me my vector of attack, like I've been talking about from the beginning, and as attackers, an attacker and a hacker especially, that's what we're trying to do. We're trying to find a vector that can get us access into the segment, be it a machine, a network, or in this case a database. And this is a database that was set up with a vulnerable application to show how easy it is to do SQL injection. And it's kind of scary here when you see this actual database is a bank, in this case First National Bank. Okay? Okay, so I'll leave that up again like I did last time, and I'll turn it back over to Rand to see if anybody's got any questions. And hopefully you got lots of them, because we've finished. I think we got good time, but about 10 minutes or so for questions probably. Rand, you can take it away.
Thank you, Kevin, for facilitating another really great session. I'm going to leave the chat box open for any questions. If anybody has anything, you can just type it in there, and I will say them to Kevin. So I'll just give a minute or so if anybody has anything to ask.
While we're waiting, one of the things is I'm wondering how many out there actually use their network traffic. Do they actually go and monitor and look at their segments, their network traffic, and those types of things? I mean, I know most people, they have a lot of the tools, and yeah, that's a good thing, but do you actually go look at the network traffic?
We have some things coming in from Frank Bishop. He's asking, when I look at some of my Wireshark traces, I see a lot of red highlighted lines. How does Wireshark relate to NIDs like snort, and how much of this is normal? On a
Okay, so the red highlighted lines first. That's just the color coding that I set up in Wireshark, and you can go change that if you want. Red's usually a reset. Usually red's a reset or something that doesn't look normal, and that's Wireshark that's making that interpretation. So if it's showing stuff that you want to see and you don't want it to show up in red, you just go into your edit preferences and you can change the color code. Some people like to have no colors on it, actually. And then Scott, you got, how does Wireshark relate to network IDS like snort? Very similar, it's just Wireshark doesn't have, you know, the rules, because the way snort works, same way Marty Resch, when he created snort, he did it because TCP dump didn't give him what he needed. So he wrote snort to give him more information. So snort applies a rule set to the same type of packets, but the actual packet capture is in the same format. Now the new version of Wireshark uses PCAP-NG. The older version, like TCP dump and all that stuff, is just a PCAP format. But it's the same concept. The only difference is Wireshark doesn't go in and apply it to a policy. Now you can go into snort and you can actually load a PCAP trace from actual Wireshark, and it'll go in and apply it and process it just like it does in snort.
Great.
So, okay, I think I got both of those, because you said how does much of this is normal. Yeah, the red highlighted lines usually is indications of something that's abnormal unless your network's generating some traffic that's being highlighted as red. So you have to tune, and I talk a little bit about tuning in some of my other classes. You have to tune the actual interface to work in your segments. But what I tell people to do is I want you to do it by segments. So when I teach defense and we do the next webinar and we talk about defensive strategies, you need to know every segment, what's inbound and outbound, or what we call ingress inbound and egress outbound. You need to know everything that's on that segment, and then you'll tune and build your policies where you bring in this case, you'll actually bring it in and you'll actually look for anything that shouldn't be in that segment, because there's too much data. I mean, yeah, there's going to be attacks that uses the same stuff you use, and we'll do other things to mitigate that, but there's too much data to track it. I mean, DreamWorks, to give you an idea, when they render, you know, the movies and they're sharing the information all on Linux clusters, by the way, which is kind of cool. When they do it nowadays, they're doing billion transactions a day plus. Can anybody go look through a billion transactions? Be very difficult to do. Even a million transactions wouldn't be easy to do. So that's the challenge we got with all the data we have out there, which is why the hackers keep winning a lot of these different things. So what you do is you set up what we call egress filtering, which we'll cover, and you don't leave things 24/7 if you don't need to. That's how we set up a lot of our banks in Middle East and Africa, is we set them up where that segment shouldn't have any network traffic at certain hours. If it does, we know somebody clicked on a link. Once again, it happens all the time. People are always going to click. They've clicked on a link, and they've actually become infected with ransomware. And then we got to go try to recover and do all the stuff we got to do from that. Okay, great. Good. Any more questions? Well, I'm waiting here for typing. So the thing is, the next one's defense strategies. The reason we set it at 14 April, of course, is my schedule, but it's also to give you time to practice. Go to the webinars, watch this webinar and the previous webinar, and practice, work with it. The way you learn this stuff is practicing. You got to do it. You got to keep doing it over and over again. I tell this to all my certification course people when I'm teaching a certification course. If they only go there for 5 days and they do it and then they leave, they take the test, they get certification, but they don't do it any good, I mean, do any more work with it after the certification, it's not going to do your employer or you any good, because it's going to be perishable. You have to keep doing this stuff over and over again. I've been doing it 25 years, and every day I do something with it, because it's like you have to maintain your currency. All right? As I said, if you have any problems, reach out, and don't get above 90% frustrated. Reach out to me, and I can try to help get you unstuck if you're stuck somewhere. And then there's a question about they missed the first class. Yeah, there's an actual recording. Rand can explain that.
Yeah, so by the end of the day, I'm going to send out the recording to everyone that attended the session, so you should all have access to that.
What about the people who weren't at the first session and they want to actually see the
Yeah. Well, everyone that has booked for the course, whether they were in the first or the second, they all get access to the recordings.
Yeah. Okay, good.
Yep.
I thought so, but that was the question I got.
Yep. So that should be all set. Okay. Are there any other questions?
I like questions. I don't know if you remember the movie Short Circuit. Like number 5, I need input. The question is, after the course is done, how do we get our certification? You will take an exam. Brand's working in each one of these and working an exam, and then a 70% passing on the exam, and you get your certification.
Yep.
Is that correct, Rand?
Yes, that is correct. That will be made available to everyone at the end, after the last session. Okay. Well, I think this is a good place to close it out. If there are any questions that come up later, you guys could always email us. We'll make sure that those questions can get to Kevin, help you out in any way that we can. Thank you so much, Kevin, again, for facilitating this session. The recording, again, will be made available at the end of the day for everyone, and we will see you all for the next session on April. Is there...
Keep practicing. Contact me. Let me know when you're having problems. I can always provide you files to give you analysis. My Udemy course, I actually have challenge files on there as well.
Great. Thank you.
Thanks a lot.